This lesson is on triangles. We're going to talk about similar triangles, and we're also going to talk about the Pythagorean theorem with right triangles. Similar triangles are two triangles whose corresponding angles are congruent, which is equal, and whose corresponding sides are proportional. So corresponding angles are the angles that match up, right? These two are corresponding here. You see angle A and angle D are congruent. You can tell by the two sets of lines. Angle F and angle C are congruent, so those are our corresponding angles. The corresponding sides, side 12 corresponds with side 3, 5 with X, and 13 with Y. Those corresponding sides are proportional. That means this long side is to this short side, so 12 is to 5, as this long side, 3, is to this short side, X. Once you have a proportion, you can solve for the missing side. So 15 equals 12x, and if we divide by 12, x equals, and if we simplify that, divide by 3, we get 5/4. So 1 1/4, so that would be 1.25 would be the length of side X. We use similar triangles often to find missing sides. To find Y, we can do it a couple of different ways. We could say 5 is to 13, so 5 is to 13. Well, which side corresponds with 5? The X, as X is to Y. Well, that helps us because we know what X is. We know X is 1.25, but that would give us a proportion that has decimals in it, and we can work that, but it might not be as nice as one that doesn't. So let's do it this week. Let's do 12 is to 13, as 3 corresponds with 12, and then Y corresponds with 13, as 3 is to Y. So you have 12y equals 39. Divide by 12. Y equals, and we can simplify that by dividing by 3, is 13/4. 4 goes into 13 3 times, so that's 3 1/4 is Y. And that makes sense. Y is the hypotenuse of a right triangle, and the hypotenuse of a right triangle has to be the longest side. The hypotenuse has to equal the longest. It's going to every time. All right. Anytime you're dealing with problems that have to do with shadows, you're going to be talking about similar triangles. The tree and this line are both going to hit the ground at a right angle. When the sun shines from up here, the angle that you get for this triangle is the same as the angle you're going to get for that triangle. Since those two are the same and they share angle A over here, all of their angles are congruent. So their sides are going to be proportional. We're looking for here what the height of the tree is, h. So we know you have the small triangle. Sometimes it's easier to break them apart. And then you have the large triangle. The small triangle, this is 3 and this is 2. For the large triangle, this is 30 and this is h. So we can set up a proportion. 3 is to 2. So the shadow is to the height, as the shadow, 30, is to the height, h. So we get 60, by cross multiplying, 60 equals 3h. So the height of the tree is 20. And we use this to figure out how tall things are when we can't actually get out a measuring tape and figure them out. All right, this is a different kind of similar triangle. You have to look at it carefully. They tell us that lines A and F are parallel. So this line is parallel to this line. And those two parallel lines are being hit by this transversal, like we talked about with the angles video, which means that this angle here and this angle here have to be congruent. They're alternate interior angles. So those two have to be congruent. Then they're also hit by this transversal, which means this angle and this angle are congruent because they're also alternate interior. And then why are these two angles right here, why are these congruent? Because they're vertical angles. So once we know that the angles are congruent, we know that the sides must be proportional. Now you do need to figure out which ones are corresponding. B corresponds with D because really these two triangles are flipped. Side C corresponds with side E, and then A and F are corresponding sides. So when we go to figure out our missing sides, that's what we would use. We could say C is to B as D, nope, C corresponds with E, right? So E corresponds to D. Let's say we know that C is, well, I'm not going to put numbers in, but there are several different ways you can do this. If you wanted to use A and B, you could say A is to B as, well, which side corresponds with A? Side F. And which one corresponds to B? And that's side D. So F is to D. And there are several other proportions you could also use that you could set up depending on what you were looking for. All right, for this one, we're going to find the length of AC is what we're looking for. They said line DE, this one, is parallel to line BC. So when they're hit by this transversal, these two angles are going to be the same because those are corresponding angles for the parallel lines. Also, when it's hit by this one, these two angles are also going to need to be the same since they're parallel. It's important in these problems that they tell you that they're parallel or that they tell you that the triangles are similar. They can give you either piece of information so that you know you can set up a proportion. Okay, AD corresponds to AB and AE corresponds to AC. So I'm going to say 4 is to 5. So this side is to this side. As now I need the long side here, 6, is to this full length, which is the one I don't know. Cross multiply, 4x equals 30. Divide by 4. X equals, that's 15 over 2, so 7.5 is the length of the whole bottom side.